What is Hermitian conjugate in Dirac notation explained? Imagine you are trying to understand how quantum states and measurements relate to each other. In quantum mechanics, we use a special language called Dirac notation to make this easier. Today, we will explore a key part of this language, the Hermitian conjugate. This concept helps us connect different parts of quantum theory, like states and operators, in a clear way. In Dirac notation, a quantum state is written as a ket, which looks like psi. Think of it as a column of numbers that describes the state of a tiny particle or system. Now, the Hermitian conjugate of this ket is called a bra, written as psi. This bra is like a row of numbers that is the complex conjugate and transpose of the ket. Complex conjugate means flipping the sign of any imaginary parts, and transpose means turning the column into a row. So, when you take the Hermitian conjugate of a ket psi, you get the bra psi. This operation is symbolized by a dagger, which looks like a plus sign with a dagger shape. Footnote. Mathematically, it's written as psi, footnote is equal to psi. This process is important because it allows us to calculate the inner product, which is written as phi psi. The inner product is a complex number that tells us how similar two states are, and it's essential for understanding probabilities in quantum mechanics. Operators are another big part of quantum theory. They are like functions that act on states to change or measure them. When we take the Hermitian conjugate of an operator, written as a circumflex footnote, we are doing the same complex conjugate transpose process but on the operator's matrix form. An operator that is equal to its own Hermitian conjugate, meaning a circumflex is equal to a circumflex footnote, is called Hermitian or self-adjoint. These special operators are very important because they give us real numbers when we measure physical quantities like energy or position. Understanding the Hermitian conjugate helps us see how quantum states evolve, how measurements work, and how to build quantum algorithms. It also plays a role in quantum error correction and in analyzing how quantum systems behave. Remember, applying the Hermitian conjugate twice gets you back to where you started, so it's an operation that is very well behaved and consistent. In summary, the Hermitian conjugate in Dirac notation is the process of turning a ket into a bra by taking the complex conjugate and transpose. It helps us connect states and operators, making the math of quantum mechanics work smoothly. This concept is fundamental for describing how particles and systems behave at the smallest scales and is a building block of the entire quantum framework.